Hello guys, welcome to our tutorial on while loops. Here we're going to first introduce the concept of loops and then we'll explore the first and simplest kind. So we're going to start by covering what are while loops, then we'll just write and run a very simple example. So let's head to the code and begin. Alright, so before we write any actual code, let's talk about what while loops are and what they bring to the table. Well, a loop in code is just a way to execute the same statement or set of statements multiple times by writing it just once, putting it within a loop, and running the loop. Okay, so this is hugely beneficial for us because we don't want to have to rewrite the same code over and over again if it's doing exactly the same thing. It's much easier to write it once, run it many times, than to write it many times and then run it once. Okay, so a while loop is the simplest form of this, and it actually acts very, very similar to an if statement. It will execute some code if some test returns true. The difference is that it will continue to execute the code as long as that case is true. So if that case never returns false, then it will always execute the code over and over again, infinitely, until the program crashes. So that's bad, but if we design our while loops carefully, we can prevent this issue and control exactly how many times we want it to run. Now, what we can do is we can simulate a very, very basic kind of platform runner. Typically, the way these games work is there's an endpoint, your current position, and then you have to get to the endpoint by jumping over obstacles, defeating enemies, etc. And the game is over, or at least the level is over, as soon as you reach the endpoint. So to simulate that, we might use a while loop. We could have an integer that represents a current position, or just pos for short. Maybe we start at 0. We'll have an integer that represents the end position. Maybe we'll just set this equal to 5. Okay? And what we're trying to do is basically keep moving forwards until we reach the end. So we might use a while loop for this. We'll basically say something like, as long as our position is less than our end position, we'll continuously execute some code. I think we're missing one of those. Okay, so in this case, we might want to increase our position by 1, so we'll do pos plus equals 1, and then maybe we want to print out our current position. So we can do standard cout, our pos, and we'll do a new line as well. Okay, so we'll do that, and then just the new line character. Okay, so let's go ahead and run this. How many times do you think this will run? It should run 5 times. Okay, the reason it runs 5 times is because our end position's 5, we start at 0. When we get to the first iteration, we perform the check. 0 is less than 5, so we execute the code. It's just increase the position by 1, prints it out, and then loops back up to the top. We perform the test again. Yep, 1 is still less than 5, so we execute the code. Now it's 2. 2 is still less than 5, so we execute the code, and on, until eventually position is equal to 5. We go back up to the top. We perform this test, and it returns false, because 5 is no longer less than 5. At which point we exit out of the loop, so we skip over this code, and that's it. Okay, then we could execute any code down here. Okay, so that's your basic while loop. Again, there is the issue that if you don't design this carefully, you can end up having it run forever. So you always want to make sure there is a way to exit out of your while loops, or that eventually they will end. Okay? Otherwise, that's pretty much it for the basic while loop. Again, really just think of it as an if statement that continuously runs rather than just runs once. In the next section, we're going to be covering the for loop, so definitely play around with while loops a bit, make sure you're super comfortable with them, and we'll learn about the next loop type in the next section. Okay, so stay tuned for that. Thanks for watching, and see you guys there. Hello everyone, welcome to our tutorial on for loops. This is the next type of loop, the for loop. It's a bit more restrictive, but that also makes it potentially easier to use than the while loop. So we're going to start by covering what are for loops, then write and run for loops, and of course compare and contrast them to while loops. Let's head to the code and get started. Okay, so previously we talked about while loops. Hopefully you're comfortable with those, because a for loop is actually going to run fairly similarly to this. Again, it's just another mechanism by which we can execute the same code multiple times. The difference here is that for loops are always going to run a set number of times. We choose exactly how many times we want the loop to run by specifying a start point, an end point, and then some sort of a step or an iterator variable. Okay, so we need these 3 items when designing a for loop. That makes it a bit more tedious to set up, but ensures that it will run a set number of times. So it looks a bit like this. We have for, we have the start condition, the end condition, and then the step variable. Okay, so to set up a basic loop, let's say that runs 5 times, what we would do is we would create an int I equals 0, so we're starting with I equal to 0. We're ending when I is no longer less than 5, and we're increasing I by 1 each time. Okay, so this is a very basic for loop that will run 5 times. Okay, again, because we're starting at 0, we're executing the code, and then we increase I by 1 at the end. We go back up to the top. I is equal to 1 now. We check to see if we're at the end condition. If not, we execute the code, increase it by 1, and so on and so forth until eventually I is no longer less than 5. Now this makes it very good to pair with arrays because we can use I as the indexing variable within an array, and then we can just set it to run for as many elements are in an array. So let's actually demonstrate that. We'll just have maybe an array of integers. Maybe we'll just do the numbers 5, 4, 3, 2, 1, so nothing terribly exciting. We're just going to create an array of ints. Maybe just be like int array. Okay, and we're just going to set this equal to 5, 4, 3, 2, and 1. Okay, so really, again, nothing terribly exciting. All we'll be doing is printing these guys out, so we'll just do a standard cout, and we're just going to do the int array at the index of I, and then of course a new line character. Okay, so essentially with each loop iteration, we're getting the int array value at the index of I, so it starts at 0, then 1, then 2, then 3, then 4, and then exits. So it will start at 5, then 4, 3, 2, 1, and then we'll exit. Okay, so if we save this and we run it, then we'll basically be printing out the numbers 5, 4, 3, 2, and 1, and there we go. Okay, so we can use I as the indexing variable, although we don't have to. We can just set this loop to run 5 times. We don't necessarily have to use I as an indexer, but that's very often where you'll be using for loops. Okay, so to compare and contrast them to while loops, essentially we'll use for loops when we know exactly how many times we want the loop to run. We use a while loop when we're not 100% sure how many times it will run, such as with a game. With a game loop, the game could be over in a minute, it could be over in 5 hours. Okay, so the loop needs to run continuously throughout that. When we're iterating through an array, there's a finite number of elements there, so we know exactly how many times we're going to be running the loop, and that's why we'd use a for loop. Okay, so practice around with for loops. I know it looks a bit more complex, but really it's no different from a while loop. It's just a bit more strict. Now, the one restriction here is that every single while loop, or every single for loop can become a while loop, but not every single while loop can become a for loop. Okay, so try and think about that. When we come back, we're going to be talking about functions. So stay tuned for that. Thanks for watching and see you guys in the next one.